All right, so at 4 we had 6.5. At 7 we had 6.2. 12 we had 5.9. And at 15 we had 5.6. All right, a tank contains, I actually pulled this straight from AP Classroom. It's similar to a release question. You could see one like this in a multiple choice. You could also see something like this. Seen it a lot in free response as well. All right, so we'll kind of walk through the idea of it and see if you guys can apply what you learned in the video yesterday. All right. A tank contains 50 liters of oil at time t equals 4. Picture a tank. Okay. 50 liters of oil in it. Oil is being pumped into the tank at a rate, RFT, where RFT is measured in liters per hour. Liters per hour. T is measured in hours. Selected values of RT are given at the table above using a right-Riemann sum with 3 subintervals and data from the table. What is the approximation of the number of liters of oil that are in the tank at 15 hours? Okay. Do you remember the idea, the introduction? I don't know what day it was, but I'm going to stop and think about it. But whatever day it was, we ended class talking about our miles per hour graph, and it was really boring. It was like 50 miles per hour for a couple hours. And the area told us distance, didn't it? Told us how far we drove. We all know that. If it was a curve, still the same meaning, harder to calculate. And so in the lesson yesterday, you guys learned that rectangles can be used to approximate. How do you draw the rectangles? Well, there's either a right-Riemann sum where, ready? You look at the interval. You look at the interval. You don't go to the value on the left, you go to the value on the right, and that is used for the height of the rectangle on that interval. So in right-Riemann sum, you actually go up to the height and you connect to the left and down. Left Riemann sum, you go to the height on the left and you connect to the right and down, okay? That's how you draw it. There's also a midpoint Riemann sum. And so from 4 to 7, are we going to use 6.5 or 6.2 for a right Riemann sum? We're going to use 6.2. So we go over here, 4 to 7. Here's our first. This is called a sub-interval. The whole interval is from 4 to 15. A sub-interval is 4 to 7. We go up to the value on the right. We connect to the left and down. Base, 3. Height, 6.2. 3 times 6.2. That area is 18.6. Next subinterval, 7 to 12. Go up to the right. Connect over and down. Now that interval is how wide? 5 times, what's the height at 12? 5.9. Now, I bet most of you didn't draw this out. But what am I trying to caution you of? You never use that 6.5 in the right Riemann sum. Are we going to use the 5.6? Yes. What about in a left Riemann sum? Would we use the 6.5? We wouldn't use the 5.6, right? Now, I think the visual might help you. Last subinterval, 12 to 15. Oops, I did the calculation. I didn't write down 5 times 5.9, 29.5 for that one. 29.5 for that one. Last subinterval. Base of 3, height of 5.6. 3 times 5.6. 16.8. Now, the calculations that got me there were I am over explaining this. All right, so 3 times 6.2 plus 5 times 5.9 plus 3 times 5.6. So 16.8 plus 29.5 plus 18.6. Did you get 64.9? Did you get 64.9? Ready? 64.9 liters. Do you all agree? The area under a liters per hour graph is liters. The area under a miles per hour graph is miles. But wait, should I put 64.9? No. What is that 64.9 liters? What does that actually mean? Put it into a sentence. 64.9 liters of oil have, who's that it? Wayne? Go ahead and say it louder. Entered the tank between 4 hours and 15 hours. That's not what the question asked. What the question asked? What is the number of liters of oil that are in the tank? Well, guess what? The tank wasn't empty. It had 50 liters of oil to start with. So we should have done 50 plus the amount that have entered. So now what do you get? Let's see. Does it make sense? That was a bit of a stretch because I haven't taught you how to do all that yet. How many of you got that right though? Okay, how many of you got 64.9? I completely understand why you got that. That's okay. I forgive you. All right. So, she's like, I didn't ask for forgiveness. Hi, Madison.
Hi.
Did you enjoy your day off yesterday?
Not really.
Sorry to hear that. Would you rather be at school?
No.
Was Noah bothering you?
No. I was writing an essay all day.
How many pages?
15.
He asked for what class?
Yeah, that's when you drop out.
When things get tough,
You
drop
drop
out.
Easy solution.
All right. So, as we get through this, these next few sections, you're going to find out there is the area under the curve, and there is a area under the curve plus this is called an initial value. All right, the initial value of that tank was 50 liters. What's another scenario? Well, we did a driving activity, right? Now, this is not a great example because I bet when you drove, you probably made a lot of turns or some turns, and it's not like how far were you? Like, let's say you started at your house. However far you drove was not necessarily how far you were from your house. House. But if you like drove here and then here and you ended up here, okay? The distance you were from your house is technically the straight line path, right? As they say, as the crow flies. Have you heard that? As the crow flies. Updated now, as the drone flies, all right? So this would be the straight line path you are from your house. So let's pretend this is a straight line distance for a little bit. If I say, here's your house, this is your final destination. But you didn't start your driving activity until you were 10 miles from your house. And you drove 18 miles. That's a lot in 5 minutes, all right? So, if I said, how far are you from your house, the area under your driving data was actually 18, wasn't it? Because you started here and you ended up here. But if I say, how far were you from your house, you had to add on how far you started away from your house, right? Segment addition postulate back in geometry. So, SAP. Yeah, you know me. All right. So, that is kind of the same idea here. All right. General questions about the lesson yesterday. What do you want to ask me? Because I know it's not as easy going watching a video. I get it. And that wasn't yesterday. It was 2 days ago. Sorry. 2 days ago. Riemann sums. Can you calculate them? Right Riemann sum, left Riemann sum, midpoint Riemann sum. Dom.
Could you go over the midpoint?
I would love to. Ooh. Do you have a calculator with you, Don?
Yeah.
Everybody else, if you don't have, if yours isn't working, please follow along. I'm in the mix. I ordered a sample new calculator, just test it out, see how it works. We may try to purchase some if we can get the money for it, kind of grant or something to get the money for it this year. I want to try to get you guys, if at all possible, working calculators for the AP test. So I'm on it. All right. We're going to do MRAM3. In the video, did I explain what that means? Okay. Midpoint, rectangular approximation method with 3 rectangles. MRAM3. All right. So 0 to 3. Ready? 0 to 3. 0 to 3. Hypothetical. Yes, Adam.
How do you know how many rectangles to use?
They have to tell you.
Okay.
They'll say like use 6 subintervals, or use 6 rectangles, or use 8 rectangles. All right. Quick little practice. Did I explain how to find the width of each rectangle in the video? Yes. B minus A over N. Because this is the interval from A to B. So B minus A over N it's the delta X of each rectangle. So obviously, if we go 0 to 3 and there's 3 rectangles, every one of them is 1 unit wide. Every one of them is 1 unit wide. But none of them will use f of 0, f of 1, f of 2, or f of 3. That's only for L, RAM, and RRAM. Ready? RRAM. This is not what we're doing. I go to the right edge. I go up. I use that height over and down. That's my rectangle that I calculate for RRAM. LRAM, I would use 0 connected over and down. 0 area, that rectangle is flat. I'm not using either one of them. I'm using the midpoint height. So at the midpoint, the height of the function at that midpoint as the height of the rectangle. All right? So this one's kind of boring. I'm going to go over to the second one. What's the midpoint of 1 and 2? Well, it's 1.5 or 3/2. I go up. That's not my rectangle. That's where I get the height from. This is the height of my rectangle between 1 and 2. And I know this sounds hokey and like, are you serious? You're like explaining how to draw the rectangle. This is the #1 missed thing on the quizzes. Like drawing a midpoint rectangle or an LR. Just make sure you understand it. All right. Ready? My rectangle is going to go between 0 and 2. This is the base. This is the height. Does that make sense? You good? Well, what about between 0 and 1? Well, 1/2. Over, down. So, area. I don't know where I'm going with that. MRAM3. Base times height plus base times height plus base times height. I'm going to write it out even though the base is 1. Reggie? 1 times blank plus 1 times blank plus 1 times blank. The bases are all 1. That's not very interesting. I didn't need to write it, but you know, placeholder. I don't want to know the value, but just tell me what I would plug in to get the height of the first rectangle. F of 1/2. Good. F of 1/2 plus F of 3/2 plus F of 5/2. Are you with me? Symbolically. Did I show you in the video how to find that in the calculator? Did I show you how to use the table and change the delta value in the table? That's so helpful. Does anybody need to see it again? Are you good? Awesome. If you need to see that again, go back to that. But you would plug that in. Did I show you how to? I scrolled through the video and I stopped at the key points. I didn't watch every single minute of myself again. That would just be weird. But did I show you how to do the table ask? I did? Okay, good. Didn't watch it, Luke? You just whispered to Jackson.
No, I'm
He
doing
said-
something else.
I'm watching. I said I didn't watch it.
I
you
was
watch it?
correcting my posture.
Yeah, what?
What did he say to Jackson?
He said, "Look, I thought you."
You really did.
Yeah.
I think if we put enough pressure on Jackson, we get the real answer out of it. He gets squirmy.
Nah, he was telling the truth.
Yeah, that's the truth.
Wendy, we need a joke. Wait, there was one yesterday.
I like your posture.
I think Mr. Parker threw it away. I wanted to tell
That's
you
a
that.
bad posture.
Oh, here it is. No, that one wasn't good. Oh, what was it? It was funny. Today's isn't really good. Did you see the dog's new outfit? It was quite fetching. It's terrible. Like the one from yesterday was pretty good, and he threw it away. But it's not in the trash. But he took it with him. Parker. All right. How did the homework go? I'll check the how many evens did you guys have? 3 of them? 6. Now, Adam, you asked about how many rectangles do you use?
Yeah.
Like number 2, it didn't say. So what does that mean? Do you know what to do if it doesn't tell you how many rectangles to draw? Because the direction, it didn't even say anything about Riemann sums. It said a particle starts at x equals 0 and moves along the x-axis with velocity 2t plus 1 for time t is greater than or equal to 0. Where is the particle at t equals 4? So we got 0, 0, 2t plus 1 looks like that from 0 to 4. This is v of t. Did it tell us how it's measured? Did not give us units. Okay. Am I supposed to do Riemann sums? How many of you did Riemann sums for this? Good. How do you find the area? That's just a trapezoid, isn't it? Where's Cole when I need him? Trapezoid. 1/2. And then we'll do it how you guys did it. Okay. 1/2. Aren't the B's the parallel bases? What's this base? 1. What's the base? What's f of 4? 9. Good. And then what's the h? 4. Did you get 20? How many of you guys did a rectangle and then a triangle? I bet a lot of you guys did it that way. Do you know where the trapezoidal area formula comes from? It looks a lot like a triangle, doesn't it? Half the base times the height. 1/2 the base times. It's half of the bases added together. Because, when you look at a trapezoid, I bet you can kind of see how it really wanted to be a triangle. It really wanted to be. It just got cut off, Got cut off. So it got 2 bases. So half the average of the base. It's the average of the bases times the height. Was that applause? Jackson, was that applause? Is that Luke? Man, you're just giving me a lot of attitude today. Is he more like this?
I'm having a. It was the cold day.
Yeah, I just can't recover. All right. That was 2. What was the next one?
6.
All right. What'd you guys? Answer's not in here for that one. What'd you guys get for RRAM for 6? 1.25. You guys agree? What'd you get for RRAM 6? Sorry, RRAM number 6. Are they redoing it?
No,
So I have Mr. Harold come in 7th grade to write Sarah down into extension.
Moving back, Mr.
That's illegal.
They took a picture of it before.
All right, what'd you guys get for MRAM from number 6? 1.83? 1.38? You guys agree? Are you getting these answers?
Yes.
Okay. Do you have any questions from 5-1? Anything beyond like 5 or 6 rectangles feels like busy work. Okay. So I don't typically ask above that. Now we have technology that can do it for us. Cool.
Which one's like the best for estimating the area?
MRAM is usually better than the others, but it's harder to calculate by hand. You know what I'm saying? All right, you guys sure you're okay on this stuff? Tyler.
Number 10 did not give us the number of rectangles used.
Interesting.
That's true. Yeah, I just guesstimated and said 4.
So from 1 to 3, you used 4 rectangles?
Yeah.
Okay. What'd you get?
1.35.
1.35? Anybody use more than 4? Did anybody use 2? Nobody else did it. How many did you use, Matt?
2.
2? Yeah, they didn't tell you, so I can't say it's wrong.
There's no right answer then, or there's a bunch of different answers technically?
Let's make a conjecture. How many of you used 2? How many of you used 4? Ah, there you go. Nobody answered earlier. How many of you used more than 4? No, I did say more than 4, didn't I? And 4 is not more than 4. So, boom, register yourself. How many of you used more than 4? Okay. As the number of rectangles increases, the sum will become more accurate. So you guys should have used like 1,000. Okay.
Sorry.
Shame on you.
Should I do that all?
And that one, I don't know why I should have caught that and then shown you guys to use 4 of them. Okay, that's my bad. 4 of them would have been fine. 8 of them. All right. What if from 1 to 3? What if I told you to use 7 rectangles? What's the base of every rectangle? 2 7s, right? B minus A, 2 over N, 7. So you have to find, ready? From 1 to 1 2/7. That's the interval. Find the midpoint. Find the height at the midpoint. You won't see me asking you to do that. All right. All right. Any other questions? Any more even questions from the homework? Is that it? Any of those you'd like to see worked out? Excellent. 5-2. May take 2 days. Most likely take 2 days. So today and tomorrow.
No way. No way.
You can't just miss a day. I mean, you gotta make it up. Back when I was in high school. Actually, I did have flashbacks. We missed so many days one year because of snow. Like we literally missed like a week straight, and then more than that. Like we had to. That was when you like every day you missed, you had to make up. We went to school on Saturdays. I'm not exaggerating. Like we went to school on Saturdays, 2 Saturdays to make up days.
That's bad.
Mental health day.
All right, definite integrals. Do you recognize? You don't need to write this down. But did you guys write down the title? Definite integrals. We're taking stepping stones today to get us to the idea of what an integral is. So, a limit is to a derivative as Riemann sums are to integrals. I'm going to say it again. We learned limits. What was the limit? Intended height of a function. But wait a minute. We want to find the intended slope. Okay, well, let's do limits, but let's do f of b minus f of a over b minus a, right? Remember how we did that? We stepped into that. That took weeks to get there. Okay? Definite integrals are a way you can approximate area, just like the limit got us closer and closer to the actual slope. But then we learned shortcuts for it. Integrals are the same way. We did the Riemann sums to get us a good approximation. And then we're going to step our way into what's called the definite integral, where we can find the exact area under any function that's integrable. All right? We'll learn what that is. And I will tell you this. The process for limits to derivatives was a couple weeks. And then we learned a whole chapter of rules. And Riemann sums to integrals is like 2 days. All right, so we're going to do this pretty quickly. It's it's kind of tedious, but not for that long. All right, so you've seen sigma notation before, haven't you? Sigma means to sum, right? Sigma means to sum. To sum. Here's an example of a sequence that has been turned into a series that you could find the sum. All right. Now, what is going to be the tedious part of today's lesson? All right. The definite integral as a limit of Riemann sum. So what do? We talked about a couple minutes ago. How can we make our estimate more and more accurate? I've got a fever. The only prescription. More rectangles, right? More rectangles. Now pretend that in the voice of Christopher Walken. You guys ever see that sketch? The cowbell? Oh, you're missing out. It's pretty funny. All right, let f be a function defined on a closed interval from a to b. What's a partition? For any partition, what's a partition? That garage door right there is a partition. What is it? A divider, right? It kind of divides 2 rooms. All right, they got partitions in LMC rooms A and B. You pull them across, they partition the room into 2 different sections. For any partition P of AB, let the numbers C sub k be chosen arbitrarily. What does arbitrarily mean? Doesn't matter how you pick, right? It's arbitrary. It doesn't matter how you pick. On the subinterval from x sub k minus 1 to x sub k. I'm telling you, this is exciting stuff. If you ask me one lesson I want to teach the day after a snow day, this is it. Yeah. All right, can I read through it and then start explaining? If there exists a number I such that the limit as the norm of the partitions goes to the 0 of the summation from k equals 1 to n of f of c sub k times delta x sub k, and it equals I, no matter how p and c sub k's are chosen, then f is integrable on AB, and I is the definite integral of f over a to b. It's fun. All right, let's break it down. College, they'd read that and just move on. Have fun next year. Just kidding. f of x. A, B. All right. P is our partition. Okay, it's divided. And I honestly, I don't know how this one's divided. I don't know if it's like 20 rectangles with a left rim on some or right at a midpoint. I don't know. Doesn't matter. Let's break it down. All right. We have, so if there are, let's see if they told us. The number C sub k be chosen arbitrarily. Okay. All right. We're going from 1 to n. So k is called an index. Have you worked with summation like this before? How many of you have seen a summation like this before? Okay, so you don't know what that means. You know it means to sum, but you don't know how it works. Is that correct? No response. Do you know how it works? Okay, thank you. So here's what happens. Oh, this is going to be fun. K is called the index. It rolls you through the number of rectangles it's talking about. And this isn't only applied to rectangles. This will go into Calc 2. This is pretty heavy Calc 2 stuff, content right here, okay? Like this is not Calc 2, but this idea is used in Calc 2 a lot. So I feel the responsibility to at least show you this. And I'm going to be completely honest with you. We're not going to be using this almost ever. Like pretty much 2 days. And it's on, the idea will be on the AP test, kind of, but not a lot. So let me touch on what I'm talking about here. Do you remember the question on the 2012 multiple choice where it had limit as h goes to 0, it had ln of, what was it? ln of 4 plus x minus ln of 4 over h. Remember that? What did I tell you to do? I said you should look at that and say that is asking me to find the derivative, right? But don't do it that way. Solve it, recognize what function, what x value, and then solve it another way. Same thing, ready? This is telling you to find the integral. They may show you something like this on the AP test, set up this way. And you're gonna be like, oh, that's asking me to find the sum of all the rectangles under the curve. I know how to do that. Here's how I can apply it. Do you understand the concept there? Okay? So all I need to do is try to show you what this is actually doing and what it means. All right? We're not going to get into the weeds of solving anything this way. All right? If that makes sense. Are we able to focus for a couple minutes? All right. This is a product. It's a product of a f of c sub k and a delta x sub k. All right. Well, what is a c sub k? Let the number c sub k be chosen arbitrarily. All right. Well, x sub k minus 1 to x sub k. So that must have been an interval. X sub k minus 1 to x sub k. This must have been one of our subintervals. What if k is 10? If k is 10, aren't I doing x sub 9 to x sub 10? All that's telling me, it's not saying the x value is 9 or the x value is 10. It's saying you are now calculating the area of a rectangle, and it's the one. So you did 0 to 1. That was the first one. 1 to 2. That was the second one. 9 to 10. That must have been the 10th rectangle. Do you agree? This must have been your 10th calculation. If k is 10, how do you know? Well, they told me to start at k equals 1, and they're telling me to go up to n. Well, what's n? N is the number of rectangles. Are there 100? Are there 1,000? I don't know. Doesn't matter. We're trusting the process, okay? So if there's 100 rectangles, you're doing this from k equals 1 to 100, and the last rectangle would be x sub 99 to x sub 100. Are you with me? All right. Okay, so all I know is that this is a sub-interval. Now, how am I doing the height? Am I doing left Riemann sum, right Riemann sum, midpoint Riemann sum? It doesn't matter. How do I know? Let the numbers c sub k be chosen arbitrarily. Oh yeah, that word means it doesn't matter how you pick it. Okay? Doesn't matter if it's a left, a right, or a middle. And it's going to be chosen on this subinterval. So guess what? I'm not going to do an LRAM. I'm not going to do an RRAM. I'm not going to do an MRAM. I'm going to do a here RAM. All right? I don't know. C sub k was just chosen arbitrarily. Doesn't matter. Why doesn't it matter? Because there's going to be enough of these that fill the interval so much that you can't even tell it's a rectangle anymore. If I make enough of those, now this one's pretty wide, just to draw it for you. If I make enough of those, do you guys agree you wouldn't even be able to tell there's a rectangle? It would almost be like little slivers, right? Base, height, just slivers. We'll get to that. If there exists a number I, what's I again? I is the definite integral. What's a definite integral? It's not a Riemann sum. It's not an estimate of the area under the curve. It's the exact area under the curve. Definite integral. Exact area under the curve. All right, so how's this going to work? Back to the story. How do you find the area of a rectangle? Base times height. Oh, look. Delta x sub k, it's telling you the change, delta, the change in your x sub k's. That's this, isn't it? That's a base. The delta x sub k is your base. What's f of c sub k? Oh, I go to c sub k, I go up, and that is my height, and I connect it over and down. F of c sub k is a height. Oh, base times height, area of that one, the purple one. Well, how many times do I do that? Well, you go from the first one to the nth one. Is that 100? Is that 1,000? Is that 1,000,000? They'd have to tell us, okay? And what do you do with all those rectangles? You add them up. You add up the base times heights. N times, don't you? That's how many times you do it. N 100 times, 1,000 times, N times. Are you with me so far? Be honest. This is not easy, all right? Hard to explain. But wait a minute, I got an issue here. That rectangle you just drew was too wide. Would you agree? It's too wide. How am I supposed to fit 100 rectangles in there if you just drew it like that? Well, we're taking the limit. I'm going to enlarge this a little bit. Enhance. This little thing is called the norm of the partitions. The norm of the partitions. Wait a minute. The norm of the partitions is the widest rectangle. Oh, so you mean to tell me they're not all the same width? No, it doesn't have to be the same width. Honestly, if I was calculating this, I would probably only do one rectangle from there to there. Do you agree? Why waste time with 100 rectangles on the interval when one would be perfect? So that's the widest one. Now, what would you do when the graph is growing steeply? If that's a word. More rectangles, right? More rectangles here. Okay, so what does that mean if they're different widths? Make the widest one go close to 0. What happens when you make the widest one get really narrow? What do you have to do with the rest of the interval to fill it? More rectangles to fill the interval, right? If the widest one is getting really narrow, you have to make more of them to fill the rest of the interval. So what's happening? Our estimate of area is becoming exact. If you make the widest one approach 0. Just like when we made h get close to 0, we were taking our 2 points we found the slope between, and we were making it 1 point. Same concept. All right? What's that called? The definite integral. All right? Now, what if they're all the same width? We'll have to hold off on that until Monday. All right? One thing to do. I don't even know if you guys can do that. You guys just got a weekend with no homework. How about that?